Hi everyone. So now let's talk about problem 3.15. So this problem is based on example 3.3. So if you haven't done example 3.3, please look back to my videos about 3.3 because this is very important. Without the basis of 3.3, I think it's very hard for you to understand the things in this question. So in this question, it gives us some different boundary conditions. So from y equals to 0 to a over 2, so it's here. Like this is y equals to 0, and this is y equals to a over 2. It is v naught, and if it is between a over 2 to a, then this is negative v naught. So it's a little different from 3.3. But what is the difference? So the only different boundary conditions is the v naught and negative v naught. Like before in example 3.3, we only have v naught. So we assume that v naught y is equal to v naught in example 3.3, but now we have two different things. So it's like, ooh. So we can just use everything else from the 3.3. For example, we can use the general solution because the general solution derives from other boundary conditions. So that's the reason we can use it. So, okay, we can use this. What else can we use? How about this form? This is equation 3.34 in textbook. Of course, we can use it because at this point we haven't applied our last boundary conditions. So that's why we can use it. So, of course, we can use this. Now things turns to some like different. Now we have v naught and negative v naught, so we need to split this integral into two parts. The first part is this. Okay, we have v naught and everything else is the same. Now we have the second part, negative v naught. Okay, and let's start this point. So let's extract some common factors. So here is just some manipulations of the math form. So nothing new. It's just to rearrange things. Okay, so now let's solve this integral. So I define this constant as alpha, so I'll just leave alpha away. So let's focus on what is that. So the first integral will become, so the sine, yes, that's correct. And we also have this constant left. So this is just the way to solve this integral. And we have the negative sign here. And we again have cosine, but we have negative cosine. So that's the same and the same. Okay, the same constant. And this one. Okay, and this two cancel. Negative a divided by n pi times, so cosine n pi divided by a times 2 over a, okay, minus 1 because cosine 0 is 1, plus the constant. I move the constant into the front, and cosine m pi divided by a times a minus, there's a parenthesis here, so be careful, m pi divided by a times 2 over a. Okay, so let's simplify this. This cancel, this becomes, okay, so let's move the negative sign inside because this makes the form better, because in this way I can extract the constant. So 2 over m pi and plus 1, and this, okay, just gone, plus, because I extract the constant, cosine m pi minus cosine m pi divided by 2. So let me check if I have the right thing. So it's always good to check if I have the right thing. Okay, it looks good here. Okay, somehow one sign is flipped. Okay, I think it's the first one. Yeah, here. It should be the negative. Okay, now it's good. Everything is good. Okay. So what happens if n equals to 1? Let's just randomly give some try. If n equals to 1, this will equal to this, and n equals to 1, 2 over pi, and we know that this is 0, plus 1, plus cosine m pi. Okay, cosine pi, what is cosine pi? Cosine pi is -1, and we also know that this is 0. So we'll find that it is equal to n divided by a, 1 minus 1, so it's 0. And don't forget, we have an alpha, so I just kick out the alpha. So of course we need to plug the alpha in when we discuss our results. What happened when n equals to 2? So let me just see. When n equals to 2, so this is cosine pi plus cosine 2 pi minus cosine pi. So what is cosine pi? -1, so this is plus 1. Okay, plus 1. Cosine 2 pi is, okay, 1, and this is again plus 1, because minus 1 is equal to plus 1. Okay, so 1, 1, 1, 1, so equals to 4, and times alpha. So 4 times m pi, and what is alpha? 2v naught divided by a. Okay, so a cancels, so 8v naught divided by m pi. This is when n equals to 2, okay? So what happened when n equals to 3? Let's see. When n equals to 3, we have 2 over 3 pi and cosine 3 pi minus cosine 2 over 3 pi, and cosine 2 over 3 pi is what? Oh, looks like 0. So 0, 0, and 1, and this is -1, so cancel. Okay, we have 0. What happened when n equals to 4? We use a divided by m pi negative cosine 2 pi. So plus 1 plus cosine 4 pi minus cosine 2 pi. So cosine 2 pi is 1, right? So this is negative 1, and 1, and 1. So they all cancel, so give us 0. And what happened if n equals to 5? And let's see. So in here you find out, so when n equals to 4, it already comes to 2 pi. And if you see the first one, okay, the first one is pi over 2, right? And what is the fifth one? If n equals to 5, this becomes 5 pi divided by 2. So it's already periodic, right? So you look at this one, and you look at this one, you will find that we started with cosine pi over 2 and comes to that. It means the rest of the things are just periodic. So we just don't consider the rest of the n because we already discovered the correct answers. So only when n equals to 2, or it's the second term in the sequence. You know, we have infinite things like n equals to 1, 2, 3, 4, 5, 6, 7, 8, and there 4 of them is in one groups, and only the second term of the groups will give us the answer. So you'll find that it's the second term, sixth term, the 10th term, and the 14 terms, like that. And when n equals to these numbers, what is Cn? So come back to our result. We've already found Cn is this, right? So this is Cn. So let's write it down. So Cn is equal to a pi divided by, 8 v0 divided by pi, when n is equal to those, right? So let's write down our general solutions, which is our final answer. So the general solutions equal to n is equal to 2, 6, 10, 14 something terms, and we have our Cn. Oh, sorry, I should write Cn before the summation, but anyway. And the rest of the terms is just the things we already know from example 3.3. So if you're really confused about how this terms comes from, so please look back to my videos about example 3.3. It has everything. So now we reach our answer. Thank you. If you like these videos, please like and subscribe. Thank you.